folks, welcome. We're finishing up our last unit here with Module 3. We're looking at complex numbers. Okay, so what are complex numbers, right? Well, let's take a look at some of these examples right here and we'll see what happens. So we're just asked to solve each equation for x, right? No biggie. So let's see here, getting the x by itself here. In fact, why don't you guys go ahead and try these, A, B, C, and D on your own before I show you the answers. Okay, so hopefully you took some time there to actually try that out on your own to see what you could do. And let's see here, if we add 1 to both sides to this equation, we get x equals 1. And there's our solution. Here for letter B, we'll subtract 1 on both sides, and we get x equals negative 1. For this one, what should we do? Well, a couple options. We could factor it and use zero product property, right? Because this is the same thing as saying x squared plus 0x minus 1. And we need two numbers that multiply to negative 1, and add to make 0, which is possible. It would be x minus 1, x plus 1. And then you can set the x minus 1 equal to 0 and the x plus 1 equal to 0. Okay? And you get x equals 1 and x equals negative 1. Okay? And that works. You could also use quadratic formula here too. I'm not going to show you that. But another way you can do it is just by adding 1 to both sides. And then square rooting, right? Because we can just get that x by itself by square rooting, and we get x equals plus or minus 1. So two different ways to do the same thing here. Again, that's why it's so important to know the different strategies that are available to you when you're solving a quadratic equation, so that way you can use, be strategic and be efficient. Now, how about this last one, though? What's our answer for this? Well, we can subtract 1 on both sides, but then we'll have x squared equals negative 1. And we would need to figure out what number, when you square it, gives you negative 1. It's a tough question. You might think, what about negative 1? Negative 1 squared gives you negative 1, right? So negative 1 squared equals negative 1. Well, what's negative 1 squared? It's negative 1 times negative 1, which is positive 1. It's not equal to negative 1. All right, what about 1 squared? Well, 1 squared is 1 times 1, which is equal to positive 1, which is not equal to negative 1. How do you multiply something by itself and get negative 1? And the answer is we don't have any real numbers that do that. Okay, this problem arose in mathematics kind of naturally as people were kind of performing it, and so they had to come up with some way to kind of like designate this because they didn't have an answer for it. And so what we say is that when you square root a negative 1 like this, you get x equals plus or minus, and then we call I. I is equal to the square root of negative 1. And this is an imaginary number. Okay? Imaginary in the sense that when people first named this thing, they couldn't really come up with a way that it applies in the real world. But it still was helpful in calculations and stuff like that. And so we had to come up with some, they had to come up with some sort of designation for it. Okay? Imaginary numbers, okay? If you think about the real numbers, that's most of the stuff that you guys work with. Okay? So that's like 1, 7, 4/3, 2.3 repeating. Okay? Pi is real. Square root of 3 is real. Then you also have the imaginary numbers. Okay, that's going to be stuff like I. 2 times I times the square root of 2. Okay, and then these two groups together are contained in the complex numbers. And a complex number is basically a mixture of real and imaginary numbers. So for example, 2 plus 3i, real part and an imaginary part, right? 1 minus I, real part, imaginary part, okay? Stuff like that. Root 2 minus, I root 7, real part, imaginary part, okay? So in the next section, we'll look at how to do addition, subtraction, and multiplication with complex numbers.